All right, so we are good now. We actually are starting the discussion, and the couple of things that remain extremely important for us. If you look very carefully at question 3, it is about coordinate geometry, or a section we call analytical, analytical geometry. We're going to work together to answer these questions. In the diagram, the equation of line AF, right, here is A and there is F, is that one, minus x minus 11. B is a point on the x-axis there. Right. Um, yeah. So B is a point on the x-axis. Um, and you have a midpoint of the line joining A and C. Okay, so yeah, so it's also the midpoint of the line. B is also the midpoint of the line joining A and C. The angles of inclination of AF and AC are alpha and 63.43 degrees respectively. You can see the angle alpha. You can also see the angle 63.43 degrees. Okay, I know that this section is a section that has been pretty much done at school already. Right, so it's revision, but yeah, we're looking at how you need to answer questions for exam purposes here. Right, so AF cuts the x-axis at E. Yeah, right, D is a point there. Here's the D is a point such that the line segment DE is actually parallel to the line segment AC. I need to calculate the value of T. Thank you so much. Let's get started. All right, to start, we are going to look at how to calculate the value of T. So how do we actually find the value of T? Right, so clearly here is actually the value, here is the T here, and T is actually the coordinate of the Y coordinate of the point A. So to actually do that one, we're looking at 3.1 and we're looking at 3.1.1. Right, so we're looking at y equals minus x minus what? Minus 11. It's actually the equation of the line there that contains the point A. Right, so in other words, this line passes through A. So this line passes through, it passes through the point A with the coordinates minus 1t. The coordinates are actually x and y coordinates. So we substitute into the equation and we get here t equals minus, the x is minus 1 minus 11, which means t is 1 minus 11, which means t is actually 1 minus 11, which is exactly minus 10. Does it make geometrical sense to say t is that? So yes, it does, because if you look very carefully, the coordinates are the x and y coordinates, and clearly you can see here that if we allow t to be minus 10, it is at a point where y itself is negative. The negativity of the y below the x-axis is a clear indication of the fact that we actually have the correct value of t. So it's something to ponder on. It's something to certainly think about. We get cracking. Next. Okay, in the diagram, the equation of line AF, right? The equation of line AF, right? So here is the point A, and here is F, is that one, and B is a point on the x-axis, etc. We read all that story. You need to calculate now the value of the angle alpha. What is the size of the angle alpha? Okay, let's do that one. And to do that one for actually a good 2 marks, so I'm gonna give you 2 minutes to try that one because I know it's revision. I'm gonna give you 2 minutes before I do it. Okay, you need to have your book, your exercise book, in which you're gonna note a couple of things, but you need to scribble during the discussions. So I hope you have the exercise book next to you with the pen. and you can, because you need to have everything in your book, then you try for 2 minutes the 3.1.2 and give me the answer to it. And then we shall do it together. What do you think the answer is? 2 minutes I'm giving to you. Okay. Please let me know when you're done. Have you seen this section before?
Yes, sir.
Okay, that's fine. It's a test. It's a simple exercise. So yeah, you'll forgive me. I
Sorry,
know
sir,
I'm saying,
can I ask something?
yes, please.
Um, I think that angle A ne, is equal
Yes.
to 180 minus the 63.4 because of opposite external angle. Is
Yes.
that correct?
Yes, that's right. Okay, that's fine. Never mind. I'm just teasing. I tease students myself. Okay, there are many things I'm going to give to you. You're well on track. But now what if the angle is asked and you can see the equation of the line? One thing that you need to realize is that the equation of the line is given. So you have the equation. The equation of the line AF, you're on point. I must admit that it's brilliant reasoning that you're bringing across. Right, so in the end, then we have that the tangent of the angle alpha is always equal to the gradient. So this is a formula. It's the formula. So the tangent of the angle of inclination is always equal to the gradient of the line there that makes that angle. So at this point, it means the tangent of alpha. What is the gradient of this line? It is what is sitting here. It's exactly what sits there. And what sits there is what? It's minus 1. Okay, so we have the tan of alpha equals minus 1. So now we need to get a reference angle. How do we get a reference angle? Right, a reference angle is obtained by taking the arctan of 1. Okay, you take the positive of that. Always take the positive of that. Right, so what is arctan of 1? Using a calculator, we get 45 degrees. You can also use special triangles for this, in which case we're able to get the following. So what is the angle alpha? So the angle alpha will therefore be the same as. So we look at the cast diagram like this. Right, in which quadrant is the tan negative? Right, you realize therefore that the tangent is actually negative in 2 quadrants. Right, it is the tangent is negative in the fourth, but also is negative in the second quadrant. Okay, I will mention that here. This one is the first, the second, the third, this one. Okay, so what is alpha? Alpha, therefore, is an angle. Now the tangent is negative. So it is actually an angle that is measured from here to there. Right, it's in the second quadrant, this angle. Right, so in the second quadrant, how do you say that? So in the second quadrant, we have 180 degrees minus the reference angle. So what is 180 minus 45? Is 135 degrees, and that is the answer. So they asked us to find the size, so the size is exactly that one. Okay, it looks like the solution was a bit lengthy, but you can do this the solution in short. So somebody would come and say, okay, we can see the gradient. So we just say the tan of this angle, alpha, is minus 1. In which case, then somebody quickly says, okay, we need the reference angle. So you can do it in 3 steps. The reference angle of this, because I know that sometimes you can be stifled by the length of the solution. So we do the arctan of 1. What is arctan of 1? It's actually 45 degrees. And therefore, what is then alpha? Therefore, alpha is going to be the same as 180 degrees minus 45 degrees. And this is 135 degrees. Why do we say 180 minus? Because to get to the second quadrant, this is 180. So you need to say 180 minus. But to get the third quadrant is 180 plus. So that is the answer, 135 degrees. Right. We need to find the gradient of AC to the nearest whole number. Right. So to find the gradient of AC, once again, during the discussion, you don't really write everything. And it's only when I ask you to try something that you can try. Right. The gradient of AC to the nearest whole number. What is the gradient of AC? Right. Where is A? This is A, and that is what? That is C. And so clearly we can be in a position to find the gradient of AC. So what is the gradient of AC? So we're looking at 3.1.3. Right, so to find the gradient of AC, the couple of things that remain very important. So we take the same thing. So what is the formula? The formula generally says the tangent of the angle is the gradient. Right, so if we're given the angle of inclination, so we're going to say the tangent of 63.43 degrees is equal to the angle of inclination, which is actually the gradient of the line AC. Okay, we use our calculator to do this one. And if you use a calculator, you realize therefore that the gradient of AC is the tangent of this, which is actually 2. So the gradient of AC equals 2 exactly. And obviously they say to the nearest whole number. Nearest whole number. That is the reason why we are rounding it off to just the nearest whole number. So we're not writing a decimal fraction there, okay? Right, so we have found the gradient of the line AC because we know the angle of inclination of the line. Next question. We'll determine the equation of AC, this one here, in the form y equals mx plus k. Need to determine the equation of that in the form that. Right, so to do that, it's very easy. 3.2. We know first things first, we know that the gradient of the line AC is 2. We know that the point A has coordinates -1 and what? -1 and -10. We got the value of t to -10 in the previous question. And this question is just a continuation of everything. And so we want to find the equation. So how do you find the equation? There are a couple of things, obviously. You can just use this formula. So you can just use y equals mx plus c. You can use mx plus c, mx plus k, because the examiner just used k here. All right, so we continue. And we are able to see that the A contains X and Y. And so Y is -10. The gradient is exactly 2. X is -1. And the K is what we're looking for. In which case, then it's -10 equals -2 plus K, which means K is -10 plus 2. What is -10 plus 2? If you transpose the 2, it's going to be positive, and we get therefore a -8. In which case, therefore, you have y equals, right? So what is the gradient? So it is 2x, the k is -8. And that is exactly the answer. But I know very well that this is not the only way to do this question. Okay, if we are asked to find the equation of the line AC, you can find it in many ways, like as follows. Okay, so we can decide that the equation is actually of the form y minus y1 equals m into x minus x1. Okay, so we have this here. But we agree that the line AC passes through a point whose coordinates we know fully. What is the point? It passes through A. So what is this? Okay, we'll continue. XY. Y is minus 10. The gradient is exactly 2. X minus, X is minus 1. So you have Y plus 10. Okay, 2 into X plus 1. Right, so we have exactly twice X plus 2. We transpose the 10, it becomes negative. In which case, therefore, we have 2x minus 8. Okay, so we can do it in either the blue way or the red method. Okay, so either the red method or the blue method, any of these methods is actually very, very applicable in solving this problem. So it's something that you need to take note of and you need to master. Okay, next question. Now we want to find the coordinates of the point C. And to find the coordinates of the point C, the marks are only 3 there. And so it's very, very easy. Okay. And so, okay. Couple of things are very important. So to find the coordinates of C, because it relates to a midpoint, you know that the coordinates of A, what is this one here? Okay, so you have X and the Y is 0 here. So if you look at the answer to 3.3.1, you would realize that this equation here of the line um, has is known from the previous question. What did you get this equation to be? We got this equation to be exactly 2x minus 8. 2x minus 8, both in using different methods. Okay, so if the equation is actually 2x minus 8, what does it mean for us? Okay, so it means a couple of things, but it means that we can, in this case, be in a position to find the intercept here. Right, we can be able to find the intercept there. What is the intercept? So we need to find first the x-intercept. How do you find the x-intercept? You let y be 0. So if y is 0, so x is 4. If x is 4, then y is 0. Okay, so you have this. Um, this is what we get. So now we want to get the coordinates of that. So we use the midpoint formula. What is the midpoint formula? So the midpoint formula is going to take, this one is xcyc. Xc plus yc. You, okay, plus that one at A. All right, so to get the, okay, these things that we're discussing now, you need to write notes out of this. So it's not that it's just a video, it's not just a movie. You need to write them down in your book and make sure that you can solve the questions, because I'm going to ask you these questions at some point to show me that you wrote the notes down and you understand. So, and that can only be seen when you can solve the questions. So if we take xc now, this is xaya. You add them up. You divide by 2. We get the x. So here the coordinates of b become 4 and 0. So XA here, that's what I'm saying. So if this one is XA here, so now you have XA, XC, you get them, you add them like that. You get the X value um, of the midpoint. Right, and then you take also, you can include YC, but you have also YA because they're the endpoints. YA, you add the Y's together, you divide by 2, and it is the Y value of the midpoint. Okay. What is XC? What is XA? It's minus 1. Okay, so you put a minus 1 there. Right, if you put a minus 1, and then what we're getting therefore is that, so you have a minus 1 here, you divide by 2, and then it is exactly 4. And then you have y at c. We're looking for that. What is y at a? Is minus 10 over 2, which is 2. So, which means you have 2 by 4, which is 8 plus 1, 9. 2 by 2 is 4, plus 10 is 14. Right, so we have 14 in that. Right. Okay, it should be 0 there because the y coordinate is 0. Just note that. So this one is actually a 0, so it's going to affect this because obviously the y coordinate here is 0 at the midpoint, so this must be 0. And therefore, right, so we have that also. This one is 0 here. So 2 by 0 is 0, and then transpose the 10, which becomes positive 10. We are in business. So what is this? Well, the conclusion, therefore, is that the point C has the coordinates X is 9 and Y is 10, and voila, we are done. Okay, so this is the answer, right? And these are the coordinates of C. They are 9 and 10. What method did you use? We actually used something here we call the midpoint. Midpoint. Midpoint formula. The midpoint formula. That is what we used. The midpoint formula. Okay, next question. The next question is want to find the size of FED. Right, so there's FED. Right, what is the size of that angle there? What is the size of that angle there? There are a couple of ways to do that one. Right, so in other words, we're looking at this angle here. And we're asking the question what the angle is equal to here. So you have ABE, right? Because if this one is 63, but this one is also 63,43 degrees. Why? Because they are vertically opposite angles. If there's an X, this angle is equal to that angle. And they are vertically opposite angles. All right. All right, to continue. Now, I want to find the size of this angle. So now, if this angle is already known, right, we know already, so we know that angle ABE is actually equal to 63. ABE is actually 63,43 degrees. Okay, that we know very well. Why is the angle AB equals that? Because they are vertically opposite angles. Okay, vertically opposite angles. So you know that. So the angles are vertically opposite angles. Okay, there's something that you need to note. Okay, so we continue to look at the next one. answer. No, this is actually ABE like that. Okay, right. The next thing is we want to find now the size of the angle E2. Right, what is the size of the angle E2 there? Okay, so the couple of angles, obviously, that you can sketch up there, right? So you can actually be able to see that if we call this one 1 and call this one 2 like this, we're able to see, therefore, that this angle, we found it to be 135 degrees. So that is the value of the angle alpha is equal to this. So which means that we can have exactly that one there. Yes. So it means therefore angle E1 is actually equal to 45 degrees. Why would this angle here be 45 degrees? Why? Well, the reason is that we have a straight line. The x-axis is straight. And so now you can use that. But there are a couple of other reasons, obviously, that a person can state there, right? So, but you can also look at the fact that this here is actually the line DE is actually parallel to the line AB. Okay, so if they're parallel, what do we do with this? Right. So if we have they're parallel, so we have a very interesting thing. Okay, but also let's just say this one is 45 degrees because of the angles on a straight line. They are adjacent angles on a straight line. Okay, so they are adjacent angles on a straight line here. Okay, okay. Now we have E2. So how do we find angle E2? So you can see this one here, like this. And then you see this here. You have this. So you have that this angle here is equal to that angle there. So what is angle E2? It is 63,43 degrees. So in the end, you have these angles in F. So if you have this, this is equal to this. So what do you have? You have angle E2 equals that. And these are corresponding angles because this is parallel to this. Corresponding angles. Corresponding angles. Why would corresponding angles exist here? Why? How? How are these corresponding, these angles? Well, corresponding angles are only observed if you have parallel lines. So you have DE is parallel to AB there. So you have DE is parallel to AB. Okay. Now, so we have this one is 45 degrees here. We have this one is 63,43 degrees. So we have this. What is angle FED? Right, so you have angle FED. What is the size of angle FED? Right, which is what they want. So it's just going to be the sum of these two. So it's going to be exactly 45 degrees plus 63,43 degrees. And therefore, we can achieve that FED is the sum of these two angles. So if you add these, they give 108,43 degrees, and this is the answer. This is the answer to the question. So we're asked to find FED, and we just did that for 3 marks. Okay. And there are many other ways, obviously, to solve this question. Okay. There are many other ways to solve this question, the answer that we can use. Okay. There are many other ways to solve this question that we can use. Right. And you can also use the idea of vectors. Right. You can also use vectors to find these. Here, I'm going to discuss that at some point. Okay, you can use vector algebra to do these. Here's another question. Okay, we read the story up there, and what we've been told is that G is a point. G is a what? Is a point. G is a point such that um, EAGC is in that order is a parallelogram. So the examiner is putting G such that if you start from E, A, then you go to G, C. You get a what? You get a parallelogram. You start from E, you go to A, then you have G somewhere, and then you have C there. It is a parallelogram. Okay, obviously you need to think about where these things are located, etc., and how this parallelogram um, is formed. Okay, right, 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 right. Okay, let's do this one. It's an interesting question. It's an interesting question. And okay, we have been told that G is a points in that order, then you have parallelogram. But what is the question? Determine the equation of a circle centered at G and passing through the point B. Okay, there's a circle that is centered at G, but it passes through the point B, right? Write your answer in the form, that one. Okay, we continue. We continue. So what is 3.4? Right, so there's a couple of things you need to note. Couple of things you need to note. If it is true that you have the coordinates of B, we realized the coordinates of B. What are the coordinates of the point B? And what are the coordinates of the point A? Right, we've seen that the coordinates of the point A are -1, -10. Right. And then we have the coordinates of the point E, for instance. Right, so they are at this point, X is -11 and Y is 0. Okay, so if you're at this point, Y is 0 and then X is -11. Good. We continue now and we solve this problem here. We want to determine, the coordinates of the point um, of the point G, amongst other things. Okay, right. So if we know this, and we know the coordinates here, we found the coordinates when y is 0, we found them to be 4 and 0. Right, we found them to be 4 and 0. Right, we found these coordinates to be 4 and 0 here. Right, so these were clearly 4 and 0. Found them to be 4 and 0. Now, with that said, what is the equation of the circle centered at G? Okay, the point at G is an arbitrary point. It's an arbitrary point. But how do we therefore find the the coordinates of this point? The coordinates of this point. Right. Irrespective of that, now look at what the examiner is suggesting. So he's suggesting EAGC. So you have E, you have A. Right. And then if you have G somewhere here, And then you have C. Okay. So this one you can remove. So this one here goes here. This one here. Okay, this is not to scale, but yeah, it's sort of this kind of a shape if G is here. And this becomes a parallelogram. Please forgive the diagram that is not to scale, and you have that. Okay, and then if this is true, you need to find what are the coordinates of G at this point. What are the coordinates of G at this point? Right, so the coordinates of G would be actually very, very interesting to observe. But you'll have to realize that X at E has those points, those coordinates there. And then now you're interested in finding X at G. Where will it be? There. So you realize that G is going to have X at G and then Y at G. Right. And so we look at these very carefully and think about what is happening here. What is happening? So if this is true in that order, I'll use a different color. Can use the same color. If I remove um, these lines here, the sides of the parallelogram, and now I have this one here. Right, and then we wish to have something like this, if that is that be the case. Right, so you think about these, and if that is sort of going to be the case, we have this. So now, therefore, you have y equals 0 and x equals 11. Now, if this is true, so we have this. So xg, yg. So we have what? Right, so at this point, you realize that y is 0. So the yg is going to be 0. You just need to get x, right? So which means, therefore, you would have x at g plus x at e. You divide by 2 because these diagonals of parallelogram bisect each other. So now if this one becomes a diagonal and that becomes a diagonal, they'll certainly bisect each other. And with that said, you have therefore that if you have x at g plus x at e, right, the result is going to be the x value at the midpoint, and the x value at b is exactly 4 there. Okay, so which means that you have xg. What is x at e? Right, x at e is actually minus 11. So here you can put the minus 11. You divide the midpoint by 2. We're finding the midpoint, and we're getting that. So this is about the midpoint formula. It's not that we are really reinventing the wheel here. So we cross multiply everything. What is 2 by 4? What is 8 plus 11? 19. Okay, look. X is 19 and that one is 0. So we have x minus that. We have that equals r squared. So which is x minus 19 y minus 0 is actually the radius of the circle. Okay, if the circle is centered at this point, right, and it has some radius. Okay, but they said the circle is centered at G, so it is G is the center of the circle, and it passes through the point B. Right, so you have that the circle is centered here, it passes through that point. So something like this. If this one is 19, then this one must be how many units? It must be exactly 15. Because the 15 plus 4 is 19. So which means the radius of the circle is 15. Okay, some of these are a little bit, they need extra reasoning. And so these are past assessment and exam questions. So you have this one is squared, right? And therefore, if you subtract the 0, it does nothing. So you get this one. You square the 15, it becomes 2, what? It becomes 225. You square the 15, it becomes 225. Okay, so next question. Right, the next question is about more interesting things, about areas and lengths. About areas and lengths. Now, in the diagram, the equation of a circle centered at N. So there's a circle, this circle here, whose center is N. And the coordinates of N are minus 12 and 5. Is x squared plus that. Okay, so that is the equation of this. The equation of the circle centered at M is this one here. PS and PR are tangents to the circle centered at M. So you have PS and PR are tangents to the circle centered at M. Okay. And at S and R respectively. So they are there at S and R respectively. PR is parallel to the x-axis. So you have PR and it's parallel to the x-axis. Okay, you can see it's parallel. So let's just mark that one. So you have PR is actually parallel to the x-axis that way. What is K? K has those coordinates minus 17 and minus 5. Okay, the coordinates are there. Right, is a point on PS. The point on PS. The straight line joining N and M cuts the smaller circle at T. Right, here is the straight line joining N and M. Here is N and here is M. Right, joining N cuts the smaller circle at T and the larger circle at S. Okay. Okay. Write down the coordinates of M. What are the coordinates of M? Right, so let's look at this one together. We just need to find the coordinates of M, this M. Right, how would you find the coordinates of M at this point? Remember that the equation of the circle centered at M is this one. So we shall look at this one. So 4.1. So it is actually x plus 6 squared. And then you have y plus 3, which is square, and it is 25. Okay, what are the coordinates of the center M? Right, so to get the center, you need to minus like this. Okay, because to get the center, you must have negatives in the coordinates. You have that. Okay. What are the coordinates of M? They are -6, -3. All right, we're done. We're done there, we're done, we're done, we're done. So if you're given the equation of a circle like this, what are the coordinates of the center? You just pick -6 and -3. Right, okay, the information above, we read everything. The circle has just been redrawn, or the circles have been redrawn. Calculate the length of the radius of the smaller circle. What is the length of the radius of the smaller circle? Right, so what is this? So this is therefore the same as x squared plus y squared plus 24. This one centered at this at n. So you have plus 24x minus 10y plus 153 equals 0. Right, so what is this? You need to complete the square here. So it's x squared. You group the x's together. So x squared goes with 24x. You take half of 24. So which means that you're going to be saying 24 out of 2. You have y squared. Minus 10y minus 10 over 2, which is the same as 153 plus 12 squared plus minus 5 squared. So which means it is x plus 12 plus y minus 5 squared is equal to 153. Okay, the 153 is going to be negative because it was here. Now we have transposed it to the other side. So it's going to be negative. We continue. Okay, the 153 is minus 153. So if you add everything here, we have minus 153, and then you have 25 here. So this is 16. Y minus 5, you square this. So which means, therefore, that r squared is 16. And therefore, r squared is 16. You take the square root both left and right. So if you take the square roots both left and right, what do we get? We get that r is exactly 4. So r squared is 16. So which means r is 4 units. Okay, because they said the length of the radius. What is the radius? So we found that the radius is 4 units. What have we done here? We were taught and we are learning from this question that given the equation of a circle, you can find the length of the radius of the circle. And we have just done that. So just note that. Just note that. Next question. Okay, the story has been read before. These circles have also been studied before. Okay. We are saying we want to calculate the length of TS. Where is T here? This one. This one. What is the length of TS? Right. Okay, there's certain things we know, like we already know the coordinates of M. We got them in the previous question. From this, we're able to see that they are -6, -3. Or we have 4.2.2. Or we want to find NM, which is the square root of x2 minus x1 squared plus y2 minus y1 squared, NM. So at this point, we continue. Right, so we continue like that. Let's pick the laser. Right, so the coordinates of M, yeah, -6, -3. So this one is x1, y1, and this one is x2, y2. So at this point, we're able to continue. What is x2? X2 is -6. What is x1? We have -12. What is y2? -3. What is y1? It is 5. So we have nm, 10 units. If you take the everything here, so it's going to be the square root of 100. Okay, the square root of 100 is exactly 10 units. So we have therefore Sm. Right, so now what is actually Sm here? Right, so we look at that very, very carefully. Here is S and here is M. What is the length of SM, which is the radius of this one? Right, from the fact that the equation is x plus 6 all squared. Right, from the fact that the equation of the circle centered at M is actually x plus 6 all squared plus y plus 3 all squared is 5 squared. So, well, it means that this is the radius. For um, obviously, it means now if you want to find SM, it is actually 5 units. Okay, take the base of the square. Then you have TS. Then TS is going to become what? Okay, which is what they want. Right, here is T and here is S. So it's going to be NM minus minus, for instance, SM. Okay, from NM you subtract SM, but you also subtract NT. What is NM? What is SM? 5. What is NT? 4, which is 1 unit. 1 unit. Okay, so we have that. Right, so we have that TS is 1 unit. They wanted us to find TS, so we found 1 unit, and that is the answer for 4 marks. Next question. Want to determine the equation of the tangent. Want to determine the equation of the tangent. PR. Okay, so you have 4.3.1. Right, what is the equation of PR? What is the equation of PR? Okay, let's look at this one, the equation of PR. What are the coordinates of R? Okay, you realize that the coordinates of M are -6, -3. The radius is 5 units, so you go down 5 units here. So if this one is -6 and you go down 5 units, so the coordinates of R will be what at this point? Right, so the coordinates of R are going to be, so you need an X and a Y. Right, so the X is going to remain the same, and the Y is going to be what? Right, the Y, you have it -3, you go down 5 units, so is -8 units. So which means, therefore, the coordinates of R are -6, -8. So what is the equation of PR now? So the equation of PR is given by right. So the equation is just y equals -8. Y equals -8. Okay. So that is the answer. Y equals -8. Okay. Next question. So now you come here to the diagram, and what is the equation? Is y equals -8. That is the equation of the line PR. The line PR, the line PR is also a tangent to the bigger circle. Okay. We continue. Um, Determine the equation of the tangent. What is the equation of the tangent? PS. Now we're looking at the equation of the tangent PS in the form that. Now, what is the equation of the line of the tangent PS? First, we must find the gradient of NM. So to answer the question 4.3.2, we find the gradient of NM. Right, N has the coordinates -6, -3. So is y2 minus y1 over x2 minus x1. So this one is NM is x1, y1. What is y2? y1, x2, x1. So this is -8 divided by 6. What is the answer? It is -4/3 dividing by 2 both numerator and denominator. Right. From which, therefore, we know that now this one here, so the gradient of the tangent multiplied by the gradient of NM is -1. The reason is that the tangent is perpendicular to NM. What is the tangent? It is what we're looking for, but now this one, the gradient of the tangent. What is NM? -4/3. So this is 3/4. But now it passes through this tangent PS passes through the point K, passes through K with the coordinates minus 17 and minus 5. And this one gives us x1, y1, because we know that one formula for finding the equation of a tangent, the equation of a line is this one here. So you have this one here. This one here. So 3 over 4x plus, okay, if you multiply this, and this is plus 5, but it's going to be negative, it's going to be 31 out of 4. So the equation, therefore, is 3 over 4x. So this one here is 3 over 4x. And then you have plus 31 out of 4. Okay, so this here is the equation they want. What is the equation of the tangent PS? It's exactly this one. So the equation of this tangent is 3/4 of x plus 31/4. And this is the answer. Okay, and this is the equation of the tangent to the bigger circle. Next question. Well, oh, just to mention, we've also written it in the required form, which is mx plus c. Y equals mx plus c, where m is 3/4 and c is 31 out of 4. Okay, in this next question, we are looking at the perimeter. Right, so the perimeter measures this, is determined by the sum of the length of the sides. Right, so at this point, if you want to find the perimeter of PS, the perimeter of PSMR, right, PSMR, you can be able to find the perimeter over there. Okay, what are the coordinates of this one? We actually realized that if the coordinates of M are -6, -3, so X is what here? Is -6, and Y becomes -8. The radius of this circle is 5 units, because we can see from 25, which is the same as 5 squared. Okay. Okay, so we are in business, and we want to find now the perimeter of the shape PSMR. So we have PSMR, want to find the shape of this. Right, so it's easy. We find that this one is 5 units. Okay, it's 5 units. And also we know that this guy here is also 5 units. Right, we know that this guy is also 5 units. This one here is 5 units, so we can find this one here. 5 units. Goodness me, 5 units. What is the length of the tangent? Okay, so we continue. Right. Right, so we want to find the length of this. Right, so to find the perimeter, we'll have to find we know the coordinates of R, but we need to know the coordinates of the point P, for example. For this one in the point P, you would realize, therefore, that Y is -8, and X is there. So you have this. What is the equation of this here? But you also know the equation of this line here, which is Y equals 3/4 of X plus 31 out of 4. Okay, that is the equation of this line. Right, so in view of 4.4.1, what we're getting here at this point is that Y is equal to 3/4 of X plus of 31 out of 4. With that said, we are in a position to substitute everything. Right, so substitute everything because we substitute the coordinates of this point. So this line here passes through. It passes through the point P with coordinates all these. You plug them into that. So this gives an x and a y to plug into the equation of, say, tangent PS. So which means y is actually -8, and this is the 3 quarters of x plus 31 out of 4. You multiply it through by 4. What is 4 by 8? Right, you know that one. Primary school is -32. So you get -32, and this is 3x plus 31. Right, so we are in business now. 3x, which is -63. You divide by 3, which is -21. What is this now? If this is the case, then it's -21. So the coordinates of P, therefore, are x equals -21 and y equals -8. Those will be the coordinates of the point P. Next, what do we do? Okay, so if these are the coordinates, what do we do next? Right, what we do next is we actually are able to make a couple of realizations here. Right, it is that the tangents from the same point are equal to each other, because if you know that x is -21 here, but x is -6, so we can be able to find PR. Right, PR must be equal to PS, which is the same as what? Which is the same as, you can take the -6 and then you add, you subtract the one ahead. You subtract 21, and what you're getting is exactly 15 units, 15 units. Okay, we're getting 15 units for the length of PR, but it is the same as PS, and therefore, but we know that the radii of a circle are equal to each other. Okay, why is PR equal to PS? Because they are tangents from the same point. Tangents from same point. Okay. Right. So we have MS is MR. These are radii. What is the perimeter? We can be able to find the perimeter. What is the perimeter? Right. So we're interested in the perimeter, and the perimeter at this point is the perimeter of PSMR. Right. The perimeter of PSMR, therefore, it's just going to be 15, 15, 5, 5. 15, 15, 5, 5. So this is going to be exactly 30 plus 10, which is 40. This is the perimeter of PSMR. The perimeter of PSMR is 40 units. And we are done. We are done. Okay. So, yeah. Next question. Right, so now we have that a quadrilateral PSMR is drawn. Calculate the ratio of these areas here. So in 442, we have that the area of the triangle NPS divided by the area of triangle, no, of quadrilateral. So we have the triangle at the top and then the quad at the bottom. Right, so we have this area of quadrilateral PSMR. What is the area of triangle NPS? Okay, if you look at the triangle NPS, the area is half. So if you look at NPS, make everything red. If you look at NPS, which is half, NS times the height SP. This guy. All right. So now we have the quadrilateral PSMR. If you look at the quadrilateral PSMR, you can add that one. You can have the two triangles here. Okay. SP and MS. MR, PR. What is NS? It's 5. What is SP? It's 15. What is SP? SP is like the 15 we got. So we're 15. Okay. And S was determined to be 5. Right, SP, right, SP is the 15 we got. Okay. But it's also equal to PR, which is 15. So yeah, it's also 15. What is MS? It's 5. What is MR? 5. PR? 15. So in the end, then you have the following. So which is half, 5, and 15. You divide everything by, it's 2 because these things are like terms. So these things now cancel out, giving us what? 1/2. So which means that the ratio of these areas is 1/2. Okay. So we have that. You have that. All right, 2 marks. The next question is about trigonometry. We shall enjoy a little bit of trigonometry of the second paper. So yeah, okay. Without using a calculator, simplify the following expression to a single trigonometry ratio. To a single trigonometric ratio. Right, so to simplify this one, we proceed as follows. Right, we have the number 1. In which quadrant is minus theta? Is in the 4th quadrant. In the fourth quadrant, the sign is negative because if you look at the cast diagram like this, right, in the fourth quadrant, this is the fourth, this is the first, so this is the second, and this is the third. In the fourth quadrant, cosine is positive, so the sign is negative there. So it's negative sine theta. In which quadrant is 90 plus? Second. So you have this one. Okay, what is theta minus 360? Right, theta minus 360. In which quadrant is that one?
The fourth one.
What do you think?
The fourth one.
The fourth one. Good. Right. So it's in the fourth one. And the fourth one, cosine is positive there. But in the end, then you get this. Right. So you have negative times negative, which is positive times negative, which is negative. So it's 1 minus sine squared. You divide by, I meant theta here. Because it's in the fourth, and in the fourth, cosine is what? It's positive. So you have these. What is 1 minus sine squared? It's cosine squared. What is cosine squared over divided by these? Is cosine squared, as rather cosine theta. So the answer is actually cosine theta, and the marks are 5. So we're done in that one. Next question. Okay, it's very important as well that as part of what you must know for the exam, the trigonometric ratios. So you must be able to understand the trigonometric ratios. Let's look at how you can use them. Like, given these here, how do you analyze the rest of these? Does the calculator write each of the following in terms of P? Like cosine 200. Okay, I've made space for that. Cosine 200. What is cosine 200? Okay, so it's easy to realize this one here because cosine 200 can be analyzed. What is this? Right, cosine 200 can be seen as cosine of 180 degrees plus what? Plus 20 degrees. Right, in which quadrant is 180 degrees plus 20? Right, so this one is in the third quadrant. Because if you look at this, I need to maybe pause for a second to talk about this cast. And then this one is cosine theta, this one is tan theta, this one is all positive, this one is sine theta. 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees. So if you say 180 plus, so 180 plus theta is here. 180 degrees minus theta is there. 270 degrees plus theta is there. 270 degrees minus theta is there. So at this point, if you say 180 plus, you are in the third quadrant because this one is the first. Okay, so 180 plus is in the third. So the cosine is negative. So what is cosine 20? It's P, which means cosine 200 is minus P. Cosine 200 degrees is clearly minus P. Next question. Okay, given that the cosine of 20 degrees is P, without using calculator, write each of the following in terms of P. Like if you have the sine of minus 70 degrees, what is the answer to this? Right, what is the answer to this? First and foremost, you realize that the sine is an odd function. which is minus this one. What is sine 70? Sine 70. Okay, you need to learn that sine 70 is equal to cosine of the complementary angle. What is the complementary angle? It's the angle that you can add to 70 degrees to get 90 degrees. What is that angle there? The angle is 20 degrees. So the sine of 70 is always equal to the cosine of 20 degrees because these angles are called complementary angles. Complementary angles. So if they're complementary angles, therefore the sine 70 is the same as cosine of the angle, which is complementary with 70, and it's 20 at this in this case, and therefore the result is minus p. So if we say what is the sine of minus 70, the result is minus p, and we are done. Kudos. We're happy. We celebrate. Okay, next question. What is sine p? Sine of 10 degrees. If you have been given the cosine of 20 degrees, which is p, what is the sine of 10? So how can you get sine 10 if you're given cosine 20? How do you get sine 10 degrees? How? How do you do this? Okay, this is how you do it. So we start as follows. Cosine 20 degrees is the same as the cosine of 2 into 10 degrees, which is 1 minus 2 sine squared 10 degrees, which means you have 2 sine squared 10 degrees, which is 1 minus cosine 20 degrees. Divide both left and right by, okay, there are formulas. You need to know, we call them the double angle formulas. You might have not seen them yet. Double angle formulae, right? The double angle formulae. So which means that if you have cosine 2 theta is the same as 2 cosine squared theta minus 1. Cosine 2 theta is 1 minus 2 sine squared theta, which is cosine squared theta minus sine squared theta. So yeah, using the second one, because cosine 2 theta has like 3 of this. Cosine 2 theta is 2 cosine squared minus 1, but it is also 1 minus 2 sine squared, but it's also the same as um, 1 minus 2 sine squared. Okay, some of the things you might not be knowing them. Okay, I'm just giving them because you will ultimately know them. Right, so you have this here. And then, but cosine 2 theta is also cosine squared minus sine squared. So we used the second version of that. So we have this. You divide by 2, which is 1 minus cosine 20 degrees. We divide by 2. So which means you have sine that, which is 1 minus. What is cosine 20? It's p, which is divided by 2 there. Okay, so at this point, if you have a square, if you have x squared like this is equal to m, it means x is equal to what? X is the square root of m. Normally it's plus or minus. So here you would have the sine of 10 degrees, which equals the square root of this, which is 1 minus p out of 2. We have this. So what is the sine of 10? The sine of 10 degrees is equal to that one. Okay, what did we use here? We used some double angle formulae. You might have not seen this yet, but you're going to see them ultimately. Okay, without using a calculator, determine the value of these. Okay, some of these obviously are very much of giants. Okay, these kinds of angles that we see here, they're called compound angle identities, which means if you have, for instance, the cosine of A plus B, what is the cosine of A plus B? Is actually cosine A, cosine B minus sine A, sine B. The cosine of A minus B is cosine A cosine B plus sine A sine B. You have the sine of A plus B is the same as sine A cosine B plus cosine A sine B. The sine of A minus B is the same as the sine of A cosine B minus cosine A, the sine of B. So at this point, because you have these, if you have cosine, cosine, look, if you have cosine, 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 sine, sine, so it becomes the negative. Um, A plus 55 degrees minus the other one, which is A plus 10. Minus A minus 10 degrees. What is A minus A? 0. 55 minus 10 is 45. So we used which one? We used the one I've put a star there because it was cosine, cosine A, cosine B, and that. So we just used that one. But if you use the cosine one, because if it's cosine, cosine with a plus, then it becomes minus. Right. And then cosine 45 degrees, you can use a calculator for that one. Okay. You can use also the special triangles. Right. So it is exactly the same as what? You can write it as 1 out of the square root of 2. If you don't want to write it like this, you can also write it as square root of 2 out of 2, which is what the Casio calculator gives sometimes. Okay, so that was the exam question there. Okay, there are some of this that you need to learn. In this particular assessment, they brought some questions like this where you had to prove some trigonometric identities. Like if you have this here is equal to minus sine and you have to prove the identity or determine the value of that. Let's look at the first one. To prove the identity, you let the left-hand side. So you have the left-hand side, which is cosine 2x plus sine 2x. So I'm copying the question as it is. But I know that I'm bombarding. I'm bombarding with a lot of information. This is cosine 2x, and then it is exactly the sine of 2x. So you have this here. So which is this one here. Okay. Like you saw before, we're going to use one of these because cosine 2x. So cosine 2x. Cosine 2 theta is the same as cosine squared minus sine squared. So you can use any of these depending on the situation. So you can use the third one. Cosine 2 theta is cosine squared minus sine squared. So cosine 2x, we're going to use cosine squared minus sine squared plus 2 Sine x cosine x minus cosine squared x. And then this is exactly sine x minus 2. Oh, okay, it's just only 2 cosine x in the denominator. So you remove this one here. So if this one is x here, 2 cosine x. For this one and this one cancel out. Sine squared and cosine squared cancel out. And they leave us with minus sine squared plus 2 sine x cosine x. You divide everything by sine minus sine x minus 2 cosine x. Right, so we factor out something. If we factor out minus sine x, you're going to be left with exactly the sine of x minus 2 cosine x, which is exactly sine x minus 2 cosine x. These ones cancel out, and they leave us with minus sine x. And they said, prove, consider this, prove the identity. So we've proven that this is actually equal to the right-hand side. So, right, so we are done with this. Just obviously take note of it. And if you have a question, you can think about it, etc., and make sure you understand this. But obviously some of these you might have not seen yet. So I'm here to give you a couple of exercises on this so that you can master this and be proficient, okay? Next question. Right, now at this point, you consider this identity, you need to determine the value of this identity. What is the value of this identity? What is the value of this identity? So we find the value of that identity. Okay, how different is it? Well, we can see that you proved that, but now you need to determine the value of this. This one here has a -3 and there's a 6. This one, the top one does not have. So it means, okay, so we have these. We have these. So look at the top one, which is cosine 2x. Sine x minus cosine squared x, which is minus sine x. Okay, so this one is sine x, like that. Okay, you factor out -3 sine from the denominator. We're left with only sine. If you factor out to divide 6 by 3, you get a 2, but it's going to be negative because it's plus. It's going to be negative cosine x. What is this here? So we have this. So we can separate this one and write it as in view of this one. Okay, you have the cosine 2x, the sine 2x minus cosine squared, but you also have the sine and the minus cosine in the denominator. So which means that we have the cosine 2x here, right? So if you have these here, so you have the cosine 2x. Okay, right. So you have the cosine 2x. And then you have the sine 2x, and then you have minus cosine squared x. So you divide these by what? You divide these by the sine x minus 2 cosine x, then you multiply by 1 divided by minus 3, the sine of x. Or what is this here? This is minus sine, so it's minus sine x. You divide by minus 3 sine x, and therefore the result is exactly 1 out of 3. Okay, you have a question? No question. Okay. Let me know if you have a question.
No, sir.
Okay, that's fine. Okay, I know that this might be a little bit advanced. Okay, this might be a little bit advanced. You might have not seen this yet. But now we're going to provide more practice on these kinds of questions. Right, so at this point, what did we do? We just took out a common factor from the denominator, and then we have minus 3 sine x, and now the cosine 2x plus sine 2x minus cosine squared divided by the sine minus 2 cosine x. We know this identity is minus sine. So you have that, and it gives us exactly this result there. Okay, next question. Right, so in view of the next question, we continue, and we want to solve this particular one. Right, in 5.4, they're actually effectively saying, for example, do a couple of things. What are they saying here? They're actually effectively saying you need to, without using calculator, show this is the only solution to the above equation, etc. Let's look at that. Right, so without using a calculator, you need to show that sine 4x is equal to minus 0.5 is the only solution to the above equation. Let's show that for 4 marks. Okay, so to show this one here, I left space here, I left space. All right, so first things first, we shall start as follows. So we shall have 3 into, you can start here and write 3, the 10 of x, 10 of x. Right, so that's fine. So you can have the 10 over x. Right, so we copy the question, which is exactly the 10 of 4x. I need to remove this. Need to write the 10 of x, not just 10x. Right, so you have the 10 of 4x is equal to minus 2 cosine 4x, which at this point becomes the same as what? Which is exactly 3 into, what is the 10 of 4x? 10 is the sine over cosine for x, which is minus 2 cosine for x, which is exactly 3 the sine of 4x, which is the same as right, which is exactly plus 2 cosine squared for x equals 0. So we have 3 the sine of 4x plus 2. What is cosine squared? is 1 minus the sine squared of 4x. And this equals 0. 3 the sine of 4x plus 2 minus 2 the sine squared of 4x. So what is this here? You can divide the board like this. So what we have achieved, therefore, is that we have 3 into the sine of 4x, right? Minus 2, I can write it differently. Okay, I can write it differently. Right, let me just write it in descending powers of sine x. Descending powers of the sine for x. So, which means from this you have minus 2 the sine squared of 4x, which is exactly 3 the sine of 4x. We divide through by negative, which means it is 2 the sine squared of 4x minus 3 the sine of 4x minus 2 equals 0. Okay, so now here we can get the factors. We can factorize this. What are the factors of this one? 2 sine squared. They are 2 the sine of 4x. Then you also have the sine of 4x. Right, the factors of the 2 are 1 and 2. Right, which means therefore when we have this one here, this one is sine 4x. You move this one to the other side, it becomes minus 1 divided by 2, and hence that result. And the other one is the sine of 4x is equal to 2. And the sine 4x cannot be 2 because the sine of 4x in mathematics is a bounded function. It always lies between minus 1 and 1. So it can't be 2. It can only be, the most it can be is 1. So you have that. But now at this point, it means sine 4x is, we have the minus 1/2, which is 0.5. This is the answer. Okay, so with that using calculator, we have to show that sine for x equals minus 0.5, and we have shown that. Next question. Hence, determine the general solution of x in the equation that one. In the equation that. All right. From the previous question, we already know that given this, the answer is that the sine of 4x is equal to minus 1/2. Okay, we already have worked this out, but we can get the reference angle of this. So we have arc sine of 1/2, which is 30 degrees. Okay, in which quadrants is this? Where is this? The sign is negative, so use the cast. So using the cast, the sign is negative in each quadrant, it's negative here, it's negative there. Goodness me, we are good friends. So we continue. We continue to solve this here. Right, so if we want to get an angle in the third quadrant, an angle in the fourth quadrant, this is the first quadrant, this is the second, this is the third, and this is the fourth quadrant. So which means, what are we then getting? So we are therefore getting 4x, which equals, right, so want to get in the third quadrant, so we're going to say 180 degrees. We add the reference angle, and then the period of the sine is k times 360 degrees. So this is 210 degrees. 360 degrees, k is in z. Divide by 4. 52. 52.5 degrees plus k times 90 degrees. K is in the integers. Okay, so this one obviously takes us to quadrant 3, excuse me. Okay, it's quadrant 3. Okay, that's fine. So it takes us to quadrant 3. And then we also have quad 4, where the sign is negative. Quadrant 4. So in quadrant 4, then you have this. So which means it's for x, so it's 360 degrees minus 30. K is in Z. For x is 330. K is in Z. You divide by 4, 82.5 degrees. K times 90 degrees. K is an element of Z. All right. So this one gives us the actual solutions. So obviously at this point, we're to determine the general solution. You might have not learned the general solution yet, okay, but just see it here because these are exam questions. So this is the most the examiners can reach when it comes to questioning. So you need to just master these things here. Okay, we are adding k times 360. You might have not seen k times 360. It's because the period of sine is 360 and the period of cosine is 360, but the period of the tangent is 180 degrees. Okay, we shall discuss the graphs. Okay, I decided to bring some of the graphs so that you are actually able to understand the periods and other things. Okay, these are the questions, but I've broken them into digestible pieces. Here is the graph question. In the diagram below, you have the graph of the f function, which is the tangent function. Right, write down the period of the function f. What is the period of f? I know very well that this is way too easy. Right, the period of the tangent function. How do you see the period of the tangent function? Right, the periods here. The period is 180 degrees. Okay, the period of the tangent is 180. It's what I was saying now. So the period is 180. How do you see the period? It's not dependent on the interval on which the graph has been drawn, but it's dependent on the coefficient. If that is 1 there, the coefficient of x, then the period just remains what? 180 degrees. So if they ask us for the period, the answer is the period is 180 degrees. Okay, next question. All right, so how do you learn from this? You repeat these questions, you write down notes, and then I'm going to send the exercises on WhatsApp for you to practice. I'm going to send some documents that, and I'm going to tell you the pages from which you need to take the problems. Okay, the exercises for you to do. Now, if you look at this one, 6.2, this graph has been given. It has been drawn between x is an element of the interval from minus 90 degrees to 180 degrees, minus 90 to 180 degrees. Draw the graph of the g of g, which is the cosine, minus cosine 2x. For the interval where x is between minus 90 and 180, on the grid given in the answer book, show all intercepts of the axis as well as the minimum and maximum points, okay, on the graph. Okay, let's look at the graph. So this one, I'm going to also teach you how to use the Casio calculator and the Sharp calculator as well. All right, normally the case when the sharp calculators are the most popular in school. So we can teach you how to use them to get the table for you to draw the graph, okay? And to do the rest of the other things. But now, how do you draw the graph of these? Here, the cosine function. So here's cosine 2x. Right, so like cosine, if you say 2 times 45 is 90 because it multiplies x, and these are like x values. 2 times 45 is 90. Cosine 90 is 0. So it's going to be a point here. Cosine 0 minus 1. Cosine 45, 2 times 45, 90. So you're here. And this one here, you're here. So you have this one here. $91. So you have this one here. 2 times, because now here you go 2 times 90 because it's 2x. So 2 times 90 is 180. Cosine 180 is minus 1. But you have a minus there, so it becomes plus. Then you come 2 times 135 is 270. Cosine 270 is 0, so this one goes here. 2 times 180 is 360. And then cosine 360 is 1, but it's minus here, so it's going to be here. Okay. So they said draw the graph over the interval on the grid, show all intercepts to the axis and everything else. Right, we have shown the intercept axis and everything. So you just need to draw on the grid. This is the grid. So we've drawn on the grid, so it must look like this. This is enough in the exam. But obviously you have that, so just label your graph and call it G. So this is the graph of the function G. Okay, that's all. Because the other one is the graph of F, which is the tangent. The examiner labeled it. Next question. Here you need to write down the range of the function G. What is the range of the function G? Okay, so you can be able to see the ranges instead of the y values, but you start from the bottom up. So it actually is from -1 to 1. So now the range is from -1 to 1. So right, so you have the range. So it is an element of the interval from -1 to 1 for the function G, okay, for G. And this is the range. So the range is a set of the y values. Okay, if you don't want to write like this, you can write like that, or you can say it lies between -1, 1, and then you have all these here, and you're done. Okay. Next question. At this point now, you're looking at question 6, and you're thinking deep. The graph of G is shifted 45 degrees to the left to form the graph of H. Determine the equation of H in simplest form. What is the graph of G in 6.4? The graph of G of X is actually the same as minus cosine 2x. But it is shifted 45 degrees, right, shifted 45 degrees left. So 45 degrees left, it means you are adding 45 degrees to X. Okay, you add and then it becomes left. It becomes a left shift. And therefore here, we have 2 into X plus 45 degrees. So G into X plus 45 degrees. So you have the cosine of 2x plus 90 degrees. G into x plus 45 degrees. So in each quadrant is 2x plus 90. Right, 90 plus is actually in the second quadrant in which the cosine is negative. The cosine is negative, so the answer is going to be negative, but it changes to the co-function using the co-co rule. The co-co rule is one way for us to realize to change to the co-functions. So now if this one is cosine, right, so cosine changes to sine. So in full, generally we have cosine changes to sine, right? Changes to sine. Okay. So we have that. So it changes to sine. So in the end of the day, this becomes the sine of 2x. G into x plus 45 degrees. So this is exactly the sine of 2x. Okay. Okay, we continue. Um, so this is sine 2x. So the graph is shifted to that. Determine the equation of h in simplest form. This is the equation of what? Of h. What is the equation of h in 6.4? So it means, therefore, the equation of h of x is actually the sine of 2x. The equation of h is the sine of 2x. Okay, so this is what we have, and this is the equation of h through a translation. So you must learn these transformations. They're part of the syllabus. Okay. Right. So very important for you, the graphs, I believe, are very important. Right. If you look at 6.5.1, you have been given the graph. Use the graph to determine the values of x in the interval between minus 90 and 90, for which the function f is bigger than 1. Bigger than 1. When is this function bigger than 1? We analyze that part, bigger than 1. Where is it bigger than 1? All right. So bigger than 1, here is the function f. Right. And here is 1. So bigger than 1 is you are here. So there's also here. So that is bigger than 1. So how do you give the answer? So in other words, the function itself, you can see that is bigger than 1 from minus 90 degrees to minus 45 degrees. So it's bigger than 1 from here to there. So which means that that is the question, the next question. I've made space. So bigger than 1, as I said, because this one is strict, you put an open circle. If they say strictly bigger, you put an open circle and you go up like this. Bigger than 1, you put an open circle and you go up like this. Bigger means you're going up. Right. So what is the answer to this? It means x is an element of the interval. Right. So you'll start from minus 90 degrees and then you go to 45 degrees negative. Okay. You go to 45 degrees negative. Or you actually consider something else. Something else. So you can also start. You can look at this one here. From here to there is also above. So you can okay, but let's see. Okay, they said you must look at the thing between minus 90 and and 90 degrees. So you need to stop here. So you don't need to take that part. So this is enough. Otherwise, you would go beyond. But yeah, the examiner said, please take this one out of the picture. Okay, so we note that part there. Okay, so this one is out of the picture. So note that. Right, so we continue. Next question. Right, use the graphs to determine the values of x in the interval. X in the interval between minus 90 and 90 degrees, where this function is like this, bigger than 0. What kind of a function is this? Right, you remember that we were looking at the function that was, what was the function g? Okay, so this is a transformation of g because the function g was, you'd remember that u of x was minus cosine 2x. And then now if you multiply it by 2, right, so, okay. We need that function there. So you would have this one, you would have this one, you would have that one, you would have this one. You'd have this one. You'd have this one here. Okay, I'm just trying to draw the graph of G we drew earlier. And then this one here. Okay, this was sort of the rough graph that was drawn for the function G. Okay, right. It was pretty much this one. Okay, but now look at what the examiner has done. They've decided to multiply this by 2 and then now subtract a 1 from it. Right, so what is happening exactly here at this point? Right, it means a couple of things, but you can transpose. So if you have a 2, cosine 2x minus 1 is bigger than 0, which means the cosine 2x is bigger than 1/2 minus cosine 2x is less than minus that. Okay, so you are saying that you have this minus function, which is the g function. So you are taking the g function and you're saying it is less than half. Where is it less than half? Okay, half is in the middle. So yeah, it's less than minus half. Right, so minus half is somewhere there. Okay, minus half is somewhere there. So it means therefore x is an element of the interval. So if you're saying it's less than minus half, you're going down from minus half. So it means somewhere here, somewhere there. Okay, but yeah, they said between minus 90 and 90. So you don't go there. You only stay here. So which means that we shall be looking at it for minus 30 to 30. You need to find out what x is here. Right, so you'd say x is the element of minus 30 degrees to 30 degrees. How do you know that here x is 30 degrees? Well, you'll have to look at what this is. If the cosine 2x is half, when is the cosine 2x equal to that? You need to solve for x. So you need to let cosine 2x be half. Okay, you divide both left and right by negative, and then, which means 2x, you get arc, which is shift cosine 1/2, 60 degrees. You divide by 2, 30 degrees. Okay, that's why we're getting 30 here. So this is going to be minus 30, but this is going to be 30 degrees. So yeah, it's between minus 30 and 30. Minus 30 and 30. So that's the answer. But also, I mean, you can say this. Okay, continue. Um, right. So we have this. What is the next question? What is the next question? So we got the answer there. So now use the graph system in the face of x, which yeah, so you have x between minus 30 and 30 degrees. Okay, let's look at this one quickly. Right. This one is very important for us to learn, but also these kinds of shapes are very important because they are geometry shapes which appear in the things we learn, and also they're important for us to learn the sine rule and the cosine rule. In the diagram, we have for that A, B, C. So you have A, B, C are points in the same horizontal plane. D is a point directly above C. D is a point directly above C. That is now DC is perpendicular. Here is DC. It's perpendicular to AC. And you have that DC is perpendicular to, here is DC is perpendicular to BC. Okay, the angle is 90 degrees there. It is given that ACB is 100 degrees. So you can see that ACB is 100 degrees. CAD CAD, angle CAD is 30 degrees. Right, you can see that CAD, angle CAD is 30 degrees. AD is 20 units. So you have that actually AD is actually 20 units and BC is 8 units. So you have that BC is actually 8 units. Calculate the length of AC. Okay, right. How do you find the length of AC? So let's just do that quickly. I know this one is very, very straightforward. So we can just enjoy ourselves and have a little bit of fun as we conclude our lesson. So the answer to 7.1.1, we are interested in finding the length of AC. What is AC? Here is AC. What is the length there of AC? Right. So to find the length of AC, it's very easy. You can actually use adjacent of hypotenuse and you use SOHCAHTOA. Okay. So now, in view of SOHCAHTOA, what do we say? So it is the adjacent of hypotenuse, it is the cosine, right? So the cosine of 30 degrees is actually adjacent, which is AC over the hypotenuse, which is 20 degrees. Right, the hypotenuse is 20 units, so which means that AC is 20 cosine 30. So, so we divide this one by 2, which is 10 to the square root of 3. Okay, 10 to the square root of 3, what is 10 to the square root of 3 using a calculator? It is 17, 32, 17,32 units. That is the length of AC. The next thing is we need to find the length of AB. How do you find the length of AB from A to B? Right, we can use any of the rules here. Right, so at this point, we want to find AB. All right, so if you look at this triangle, you can take it out. So you have B, you have A, you have C. So what is AB squared? Which is AC squared plus BC squared minus 2 minus 2AC minus 2AC BC cosine, because AB is opposite the angle C. Is opposite angle ACB, cosine rule. So which means that we have AB squared. What is AC? We got it from the previous question. AC is 10 to the square root of 3. So what is AC? What is BC? So what is this one here? So what is AB? Which is 20,30 units. So AB is 20,30 units. So when did the length of this one? So it is ideally approximately 20,30 units. Okay, that is the length of AB. Next question. Right, at this point, we want to find also the if it is further given that ABD. So you have ABD, so there's this angle here, and it's given also 73, that. So if this angle is 73,4 degrees, calculate the size of ADB, right? Of ADB, what is the size of ADB, right? So you can use the sine rule there, because if you have this triangle here like this, and you call this one 73,4 degrees, so you call this one B, and you call this one A, you call this one 20 units, like this. Okay, we're here to practice these things. I'm here to give you lots of practice exercises for you to learn and master this. So at this point, but you need to repeat this and go through this and write the notes, and I'm going to send you on WhatsApp the exercises. So now you have this. If this one is D, What is the length of B? So it is the sine of ADB. What is the sine of this? Okay, so you take the sine of ABD over AD. So you have the sine of ADB, the sine of ABD. Now you take the B and the D. Okay, the sine of the, I'm crossing the thing now. I should not cross the thing. Right, so we have this one here. Okay, so you have the sine of ADB. So um, okay, continue. So this one now, if you take the sine of this, country that is running over the thing here. This should not run over. Right. So if you take the sine of ABD over the opposite angle, over the opposite side, excuse me. So opposite angle B is 20. Okay. So you have the sine of ADB. So which is 20,3. What did I say here? Yes. 20,30. It's like 20,3, which is the same as the angle B, you already know that. Okay, note here. This one here is actually the size of ABD, so it is the angle B. Is ABD, so it is actually the size of the angle B, that is 73,4 degrees. So, right, so here you have 73,4 degrees. So now, okay, so you have this. So what is the sine of this? You divide by 20. So which means ADB, okay, you take the arc sine of 20, the sine of 73,4 degrees, divide by 20. Which is 76,58 degrees. Okay. Right, they wanted the size of the angle ADB, so we have found that the size of the angle ADB is actually 76,58 degrees. Okay. Right, I think that this is enough to conclude our discussion for today. So I must thank you for joining us. I'll see you again tomorrow. please think of the time at which you can meet tomorrow so that we have our discussion. I'm going to send the recording in the next few minutes, okay, so that you can watch and take notes, etc. But I first load it on YouTube. But you see, when I load the video, it will take a couple of minutes for it to be settled and be very clear and run well, you know. So sometimes after loading it, it's still unstable, but after some minutes, it's going to be okay and you can watch it. But I'm going to send you the link in the next few minutes after uploading the video. It takes a couple of minutes for me to upload the video. But yeah, but thanks a lot then. I'll see you tomorrow. Please confirm the time at which you're going to be free tomorrow. Okay, for life sciences. All right.
Okay, thank you, sir. I
Okay.
think we can
Thanks. Yeah. Yeah. See you tomorrow.
tomorrow.
All right. Thanks. Goodbye.
Bye.
Mhm.